Hello everyone, welcome to the channel Code Like. Guys, if you find this video helpful, please like this video and subscribe to the channel. Now let's see the second problem of the weekly contest 506. Frequency balance subarray. You are given an integer array nums. Define the frequency balance subarray as follows. If the subarray contains only one element, it is a frequency balanced. If the subarray contains at least two elements, then every element with the maximum frequency must occur exactly twice as many times as every other distinct value in that subarray. Return an integer denoting the length of the longest frequency balanced subarray. A subarray is a continuous non-empty sequence of of elements within an array. The frequency of an element X is the number of times it occurs in the array. So in this question we are given an array nums and we need to find the maximum length of the frequency balanced subarray. How it is defined? If the subarray contains only one element, it is a frequency balance. No need to worry. If it contains at least two elements, then every element with the maximum frequency. So the element which is most occurring should have its frequency not twice as the every other distinct value in that subarray. So let's see the constraint here. The constraint here is num sort length is 10 to the power 3. So the n square solution can be done here. So let's see the example here. We have nums as 1 2 2 1 2 3 3 3. The longest frequency balance subarray is 2 1 2 3 3. So the maximum frequency elements are 2 and 3, each having frequency 2, and the distinct value other than this 2 or 3 is 1. So 1 frequency is 1, so 2 into 1 is equals to 2. The 2 and 3 satisfy this condition, so this is a frequency balance subarray. How we can find this? What we are going to do is we are using two loops to iterate over every possible subarray, and we will be maintaining a frequency map in a map, an ordered map which will be the frequency map. The maximum frequency can be 1 because it is given. If it is subarray, at least we can find a subarray because at least one element should be there in the array, and if we are using that array as a frequency balance, we can say that it's a frequency balance according to this condition. So while iterating over every subarray, we are just adding it into the map and increasing its frequency count. If our maximum frequency count, if the current element's frequency is greater than or equal to maximum frequency count, we are just we can also make this as greater than. We are just storing it in the max frequency, and now we are checking if this is a valid frequency subarray or not. So we will be having a boolean valid answer. We will be initially making it as true. If the maximum frequency is 1, then we don't need to check because uh, we know that we can have answer of maximum frequency equals to 1, so we will just continue. We are using two variables here: distinct integer count. It means the how many elements are present in the map, and the maximum frequency integer count. It means the maximum number of integers, the number of integers that having the maximum frequency. So while iterating over the map, we will be incrementing the distinct integer count. It will be the size of the map as well. And if the p dot second, it means the frequency is equal to the maximum frequency, then we are increment this maximum frequency integer count, because this variable holds how many integers have the maximum frequency. And if the current element have the maximum frequency, we'll just continue because two or more elements can have the maximum frequency, like this 2 and 3 having the same frequency as 2, which is the maximum frequency. Else if the element we find doesn't have the frequency as maximum frequency, we will check if p dot second into 2, it means the maximum frequency should be equal to this 2 times the frequency of the current element. If it is not, then it is not valid answer. We will just make it as false valid answer and break the loop, and in the end we will check if it is valid answer. And this condition is important here. We're gonna check if distinct integer count is greater than 1. It means we have more than one element, more than distinct element in the map, and the maximum frequency and the distinct integer count is equal. It means for example, we have something like what we can say 1 2 3 4. So the distinct integer count here will be 1 2 3 4, and the maximum frequency count will be 4. This should not occur here because in that case the answer will be 1. So this condition should not hold. For example, let's see this case. I think for this case we will be getting answer is not. For this case we will be getting a different answer, incorrect answer. So this condition is important here. So this condition says that we should have the distinct integer count and it should not be equal to the maximum frequency count. So in the end, we will be just storing the maximum of the size of the subarray and just returning it. Time complexity will be big of n square. It will be greater than big of n square because for big of n square for we iterating over the every subarray, and we are iterating over map as well. Space complexity will be big of n because we are using the a lot of map here. So guys, if you find this video helpful, please like this video, subscribe to the channel. Thank you.